On Steve, I'm going to show you how to graph a sine function. The first thing you need to know when graphing a sine function is the amplitude. The amplitude is usually found in front of the equation. So for this one, the amplitude will be found here. There's nothing there, so it's assumed to be 1. That means that the graph is going to go from positive 1 to negative 1 on the y-axis. So from here to here. For this equation over here, the amplitude is 4. Okay. That means that the graph is going to go from positive 4 to negative 4 on the y-axis. So from here to here. And that's the amplitude.
Hi, I'm Matt. I'm going to talk about the period of a sine function. So to start with, you have to get a basic idea of where the period comes from. It comes from something called the unit circle. And what the unit circle is basically just a circle. That picture is quite awful. But it's a circle and it goes from 0 to, in radian measure, pi over 2, which is the same as 90 degrees, to pi, which is the same as 180 degrees. Get 0 around the circle, halfway, 180 degrees. And then this is 3 pi over 2, which is the same as 270 degrees, which is 3/4 of the way. And then over here can also be called 2 pi. So essentially, one sine function goes all the way from 0 all the way around to 2 pi. So one sine function occurs once in 2 pi. It occurs once in 2 pi. Yes, that's it. So what happens is, with the period, because this is just regular old sine of x, the period is going to be equal to 2 pi, which is because of this. Which means that the sine function is going to start at 0, which is here, and go all the way to 2 pi with one period, one rotation around the circle, if you got that. And then, so it's going to start here, and a sine function goes sine function goes up and up. So, whoops, that's not right. I lied. I'm gonna go there. So that is one period of this sine function. One period goes from 0 to 2 pi of this sine function. Then this one is a little more tricky, because where this period usually shows up is it's in between. It's usually like right here. It's in between the sine and the x value. Because there was nothing over there, you assume it to be 2 pi, or which is like 1 pretty much. So it's right there. So what's going to happen is that you're going to have to factor out this 2 out of these parentheses. So when you do, you're going to get 4 sine of 2, and then x minus pi over 2 plus 2. And now this 2 will help us get our period. Let's see. To get the period using the 2, use this formula. It's 2 pi over b, where this value right here is the b. So 2 pi over 2. So that means the period of this function is pi. Which means that if you take this and just squish it, it's only going to go from 0 to pi instead of 0 to 2 pi. So the graph is going to go from 0 to pi instead of all the way from 0 to 2 pi, because one rotation, instead of going all the way around, well, it still goes all the way around, but like the circle is more squished. So it goes from 0 to pi instead of 0 to 2. So it's just more squished versus more spread out.
Hi, I'm Slade, and I'm gonna explain the vertical shift and sine function. The vertical shift is a number at the end, which determines where the graph is centered around. Sine of x doesn't have any number at the end, which means that it is centered at 0. So this graph has plus 2 at the end, which would read the graph as a graph up 2, which would center it, which would be centered at 2, and the highest point would be 6, and the lowest point would be negative 2. The graph would be redrawn the same, just up 2 units. This is the difference between the old graph, which didn't have any number at the end. This is the transformed graph.
Hi, I'm Liz, and I'm going to teach you how to do the phase shifts. Now, when you look at the sine function, on regular ones, the original one, there is no phase shift. A phase shift is moving the graph left or moving the graph right. So this one, obviously, the center is at 0, 0, and it doesn't move left, right. When we move to this one, you find the phase shift inside the parentheses with the x. Now, when Matt did the period, he took the 2 out of it so that it's x minus pi over 2. This number right here, this is the phase shift. Now with phase shifts, left, right always lies. So since it's negative pi over 2, that means you want to move it in a positive pi over 2 direction. So if we look at the graph here, so this has no phase shift, this has pi over 2. So if we're going to move the entire graph pi over 2 to the right, then the origin, instead of being at 0, 0, is going to be at pi over 2, 0. But we have to remember the vertical shift too that we did earlier, which is up here. So the graph of this, when we put all the pieces together, goes from negative 2, but over pi over 2. We have to remember our period as well. So this is where it's going to end at 3 pi over 2. Okay. So the pink line is the final graph with the period, with the amplitude, phase shift, and the vertical.
Alright. A cosine graph is graphed the same way as a sine graph in that you need to find the amplitude, the period, the phase shift, and the vertical shift. However, a cosine graph starts at the top of the amplitude, whereas a sine graph starts in the middle. If you look at the cosine graph, you'll notice that it's very similar to the sine graph, only pushed over. So if I were to push this over, pi over 2, it would look like this. Doesn't that blue look similar to that blue?
Sure.
Hi. Hi, I'm a sine graph. Phase shift, 3 to the right. Vertical shift, 2 down. Phase shift. 2 to the left. Vertical shift. 1 up. Now what do we do?
Dance.
Turn around. Papa l'americano. Papa l'americano. Papa l'americano.
Hashtag YOLO! Hey, the lore ride was awesome. Do you want to go to Panero?
I don't like Panero.
I don't care. Come on, come buy me things.
I don't want to go to Panero. Dana, stop.
Mama fall. I took 4 AP exams and I don't even care about this project right now.
What's poppin', y'all? Well, I'll catch you on the flip side.
Satish!
Papa l'americano.